Welcome to Abdul Academy. In this series we will be seeing with respect to IoT, and we will uncover knowledge on the infrastructure, sensor technologies and networking technologies of IoT.
Welcome to Abdul Academy. In this session, we'll be seeing about 4 communication models with respect to Internet of Things. So the 4 communication models with respect to IoT is, the first one is the request response model. Second one is the publish subscribe model. The third one is the push pull model. And the fourth one is the exclusive pair model. Request response model works based on client server model, where the client is always the one who requests for a service or the resource, and the server is always the one who provides the services to the client and responds to the services requested by the client. In this case, the client requests to transmit or upload the data from the server. Based on the request received from the client, the server does these steps. First, it determines how to reply to the request received from the client. Second, it acquires the data based on the request received from the client. Third, it fetches the representation of the resources based on the client's request. Fourth, it sends a response to the client. The client, in this case, can be an IoT device. HTTP usually works on request response protocol, where your Google Chrome, the web browser, can be a client, and mail servers like Gmail, Yahoo Mail can be servers. So if you look at this architectural diagram, the client sends the request and the server prepares the response by doing these 3 steps. Determines how to reply, acquires the data, and fetches the representation of the resources and responds to the client based on the request from the client. Second one is the publish subscribe model. Publish subscribe model has 3 entities: publisher, broker, and a consumer. Publisher always publishes the data on a particular topic to the broker. Consumer always subscribes to the broker on a particular topic. Let us say, for an example, a publisher has subscribed on a topic X1, X2, X3, and the consumer has subscribed for a topic X3. What does the broker do? It does a matchmaking. So based on the subscription done by the consumer to the broker directs that particular message to the particular consumer according to the subscription done. So the publisher will publish the topics to the broker, and after the consumer has subscribed to the topic on a topic to the broker will do a matchmaking based on the topics. So if you see, there are 3 entities: publisher, broker, and a consumer. Publisher publishes the topic to the broker. Consumer subscribes on a topic to the broker. So based on the matching of the topic, the broker will direct the messages to the particular consumer, what the publisher has published. So this diagram will give you a clear-cut picture. So publisher has published on a topic called as an area 1, has also published on a topic called as an area. This consumer 1 has subscribed for a topic area 1. This consumer 2 and consumer N has subscribed for a topic area 2 based on the subscription to the broker. So the area 1 has been given to the consumer 1, and area 2, what the consumer 1 and consumer N has been subscribed to the broker, has been diverted to consumer 2 and consumer N based on the subscription. So basically, the publisher publishes on the topic, the consumer subscribes onto the topic. So what does the broker do? It does the matchmaking based on the published topics and based on the subscribed topics. The third one is the push-pull communication model. In push-pull communication model, it works on producer-consumer, where producer is the one which pushes the data and the consumer is the one which takes the data, that is, pulls the data. So producer pushes the data, consumer pulls the data. Now, where does the producer pushes the data and where does the consumer consumes the data from? From the queue. From the queue. So the producer pushes the data to the queue and the consumer pulls the data from the queue. Both the producer and consumer are not aware of each other. How they are pushing, at what rate the consumer is consuming. Okay, at what rate the consumer is consuming, the producer is not aware, and at what rate, okay, the producer is producing, the consumer is not aware. So now what happens when the queue is not there? So for example, when the producer is producing at a rate X the data and the consumer is consuming at the rate Y. So producer is consuming at a rate X which is very high, let's say for example, and the consumer is consuming the data at a rate Y. Okay, there might be a scenario, okay, the speed at which the data is coming to the consumer might be very high and the consumer might begin to lose its data. So what happens to avoid this delay or to avoid this error? So we go for a concept of queues where the producer is producing at its own rate and pushing the data to the queue, and the consumer is consuming at its own rate Y and taking the data from the queue. So the producer produces the data at a rate at which is faster than the consumer can download. So if we bring in the concept of queues, this particular error is avoided. So publisher publishes the data or pushes the data to the queue, and the consumer pulls the data from the queue. So the messages are being pushed at a rate X and the messages are being pulled, that is taken up by the consumer at the rate Y, and the producer need not be bothered about the consumer consuming the data at which rate, and the consumer need not be bothered at the rate at which the producer is producing. But if the queue is not there, the consumer might lose its data. So that is why we bring in the concept of queues. This is how we use the concept of push-pull model. The third one was push-pull model. And the fourth one is the exclusive pair model. Exclusive pair model works with respect to client server model. So on one end we have the client and another end we have the server. So the client requests for the server and the server responds to the client. Once the client and the server connection is established, okay, for a connection is established, there is a continuous communication between the client and the server. Not, okay, all the messages and all the transactions between the client and server happens in a one session. Unlike the other protocols where once the connection is established, if the client wants to send another message to the server, again a connection needs to be established. A separate session needs to be established. But in exclusive pair model, okay, once the connection is established, there is no need for separate session. The connection is there till the client goes ahead and closes the connection. And it is bidirectional, where the client also sends the data and the server also can send the data to the client. So it's a bidirectional and it's a two-way communication between the client and the server. So it is a bidirectional and it's full duplex. And once the connection is established, okay, there is a steady flow of data from the client and the server, client to the server and from the server to the client. Till when? Till the connection is closed. And it's a stateful connection model. Server is all aware of all the open connections. So if you look at this diagram, there is a client one wants to get connected to the server. So he first sends a request to the server that I want to establish the connection with you. Server, on receiving the request from the client, sends an acknowledgement, your request has been accepted. That happens in the second step. Once the connection has been established between the client and the server, the messages gets transferred from the server to the client and from the client to the server. Okay, you can transfer n number of messages can flow from the client to the server or from the server to the client. You need not have a separate session for each message. So the connection between the client and the server will be live till the client sends up a connection or request to the server telling that I want to close the request. So the connection from the client and the server will be valid till the client sends a request to the server to close the connection. Once receives the request from the client to close the connection, the server goes ahead and responds to the client for closing the connection. Once the connection is closed, the transaction ends. So this is how the four communication models with respect to IoT work.
Thank you for watching. Click on the subscription button to receive notifications on upcoming videos.